what we'll do is basically, if you go to the documentation, we'll follow a bit along, but we also explain the documentation. The idea is to like help you also understand and like get a bit of a feeling how to find stuff in the documentation. And I want them to do this alone, but together with my colleague Radovan, you met yesterday already. And you?
Yep, looking forward to. So Radovan passed same corridor as Jørn, University of Tromsø, and what I will try to do here is to follow along. I will try to ask Jørn questions to adjust the speed, the level, and so that we have a really common understanding.
That's the idea. Okay, so let's start. I mean, I guess, do we have to motivate much why you want to install software? But maybe you can, like, Radovan, you can tell me, like, what you, back in your researcher days, what kind of software did you use and would you install it, like, on these clusters? Oh, so now, of course.
So back in research time, it was mostly Fortran and Python. For a long time, I thought that I cannot install software on my own. And so for a long time, I thought that I'm not allowed to. It's only, I don't know, like 5 years later that I learned that actually I can install software myself, also on a cluster. The Fortran software I was installing myself through makefiles. For the Python software, I did it wrong because I tried to do it the same way I do it on my computer. And back then what I tried is sudo pip install, or it was even called differently, easy install or something. So only later I learned about virtual environments, about Conda, about isolating environments, about documenting them. So I did it either wrong for a long time, or I thought that I'm not supposed to, allowed to, able to. How about you?
Mostly Python. But of course, sometimes you also come around to other software, and yeah, we will show you a bit. Like, you can install a lot of software yourself. I mean, in theory, you can basically make almost everything run yourself, but sometimes this is hard, and sometimes it also makes sense to install it globally for everyone. But this is something, I mean, you have to send in a ticket, it can take time, so knowing how to do it yourself and to get like the newest version or like something like fast is a good skill to have. And I saw that here someone said like ComSol and Congender Genius. And someone else was asking about like how to open Jupyter notebooks. Okay, we can try to tackle those questions as well. But I think everyone, let's first find the page about actually installing software. I think we talked about using modules already. So to find the software that you're using on the systems, which are basically already like the install software. We tackled that, I guess.
Yeah, because I wanted to ask, because you mentioned installing globally, so I wanted to ask what that means. Mm-hmm. And I think when we talk about globally, we will also talk about modules.
Yeah. So here on the documentation on the left side, which so everything is a bit compressed, but the idea is that you then later have time also to like work along. We have here a list like how like the software module system, which is based on like on the command module, or so for example, I'm now in Saga. If I want to see, let's make it a bit larger. For example, I want to see if there's Python installed. I would type usually something like module avail, and then Python. And then I see like, okay, here's a couple of modules. Maybe. And then, for example, like if I want to see what, I mean, this is kind of self-explanatory, I guess. And basically we discussed it in some earlier courses, but this means it's a Python like 3.10.8. But this is always a bit confusing. What does this mean? Like this GCC core 12.2.0. Can you help me there?
Yeah, so that's a tool chain, but what does that mean? So that, do you want to explain it? Should I try to explain it?
Well, maybe we can try it together. So that's, if I understand correctly, means is what kind of like compilers and libraries in the background the software was installed, which is something which in Python you don't usually think about that much, at least in my experience. Like what kind of compiler was used to compile Python is something which is usually not.
Yeah, we don't think about it.
Yeah.
Because with Python we think it's not a language that compiles, it's a dynamic language, but of course the language itself needs to be compiled. And the naming here comes from this framework called Easybuild, which we will probably come back to in a moment. And in Easybuild, the idea is that everything should be as reproducible as it can be. So we keep track of not only the versions of Python here or SciPy bundle, but also the versions of what was the tool that built that tool. And this is the tool chain. So in this case, the tool chain would be the GCC core, and the GCC, I guess, stands for GNU C compiler. And then sometimes the tool chain is Intel. So different compilers, different tool chains to build other tools, like Python.
Well, like here we can also see FOSS, which is
free open source software.
Yeah, it includes GCC core, but contains also other libraries like math libraries like NumPy or BLAS, something like that. So basically, you always, for each module, you have the name, or like the software, and then the version number, and then usually with which toolchains or with which compilers it was installed. And the toolchain sometimes can be like a bit of an issue because they have to be more or less compatible when you load different modules. Okay, but let's see. The one which like is a bit weird is this one, the SciPy bundle. Like if you know what SciPy is, if you have used Python, this is like a bundled where like NumPy and actually I don't know what else is there. Do you like NumPy Xera? I think pandas
and SciPy.
Yeah, SciPy of course. But like to check now out. So instead, you can always write a module, and then what I like to use is spider, and then we copy just the whole thing. So the complete name of the module, and then you will get some extra information. So here, it's a bundle of Python packages for scientific software. You will need to load bundle. This one is interesting. It includes extensions already. So we see, okay, it contains SciPy. So it has a lot of pre-installed Python modules. PLI, pandas, NumPy. Some I know, some I don't. For example,
is it just me who cannot see the bottom of this thing, like where you type? I see the commands, but somehow I don't see you're actually typing. But maybe. Is it just me?
I don't know.
No, it's the same for me. I see two sections on your screen.
What can you see now? Can you see this included extensions part?
Yes, yeah. I can see the included extensions, but you were also typing something below that, and the thing below that I don't see.
This one, but you don't see my prompt.
I don't see a prompt, no.
Oh, this is weird. Let's try what happens if I reverse the order. Does it work now?
Nothing changed here. Now something changed. I think that's better.
Yeah.
Okay, good. So, okay, good. So, but here you see, for example, that this Python, this module or the Python package contains like not only Python, but also like all these modules. So if you, for example, only use NumPy and pandas and maybe SciPy, you can just use that and everything is included.
And I think now we need to be careful about the name module. So what exactly is a module? So I see a couple of Python packages here.
Yes.
But what is a module? And maybe you wanted to say that later.
No, we can do it now. Okay, let's start why we actually need modules now. Like of a detour, but and if you think this is, you can also always write a comment in here if you think something like you need details.
I think it's a good
small course, so we can.
Yeah, it's good good question. Why do we need modules?
So modules come from the need an HPC system is a shared system, so we have lots of users. There's all very different like needs for in software wise. Like someone probably needs Python, someone wants to like combo, someone wants an open chemistry software or a bioinformatics software. And you can of course install all of those at the same time. But what happens now if there's two users who want to have like two different versions of the same software? Like someone wants to have OpenFOAM, which is a chemistry software. Someone wants OpenFOAM version 2.5 and the other one wants 2.7. Then it gets a bit more complicated. And of course you could like have like OpenFOAM, like something like that. Yeah, now I got right. OpenFOAM 2.3 or something like a suffix, but that's also then a bit clunky and you have to adapt all those because it's not how usually software is called. So the module system helps with that because it means we can install a lot of software, but it's not available to you at any moment, but you first have to load a module. And the module is basically just a very short like Lua script, which describes like what paths to add and how to make this module, this software available to you. And we can also actually like see how one of those look. Maybe I still have it. Oh. Dang it. I thought I had maybe it's still loaded. Here. You can have a look at this. This is how the module actually looks like. Here you see where it's saved. You see a help desk. This is part of the help function. This is the same description that we saw earlier. And then here's what is description, a bit of your URL, extensions, and then what it actually loads in the background. So it loads a Python 2.7 version. That's unexpected, but good to see. And then it puddles around with the path, library path, and the prefix path, and here especially important the path, which means it makes it available to you if you just type Python now. All the binaries which are in this SciPy module or installed with that are then added to the commands you can just type on the and will be picked up. Was this too confusing?
I think it was good. Maybe one thing you could try, just module avail without anything, to see that we have really, I don't know, hundreds, maybe more, of different softwares. So these are codes that somebody asked us to install, and so we have all these different versions. And so it's like a huge menu. So it's a restaurant with a gigantic menu, and now you can select what you want to have on your table. And that's the module load. So we can selectively load the modules that we want to have in my environment for this calculation that I'm trying.
You see that like this breaker, the software there's only one version available, while for example the BWA, which I think is a biochemistry software, there's two modules with the same number actually, but like slightly different toolchain versions. So this is 0.2, this is 0.3. But also do we have somewhere it's like here, for example, BX Python, there's like 3 different actual versions, 0.8, 11, 0.8, 13, 0.9. And so you can load or like whatever of these is interesting to you or you need, you can load. And I guess most people here probably like loaded already like somewhat now. How do you like, should I just load the SciPy maybe? No? Oh, maybe I first show what actually I already have loaded, and you can do that with module load.
You want to do module list?
Oh. Thank you. Already a bit confused. Yeah, okay, good. Then we have a standard environment, which is always basically loaded. And I actually also don't really know what this does. It's just like set some defaults and some basics and makes the whole system available to you. Do you know better what standard env does?
Like what is inside there? I don't exactly know.
Yeah, we can try it out. Adds cluster module files to module paths. So it actually makes the modules available to you by adding them to the module path, which is a variable which contains a list to like a link to all the modules, which you can search into. Good. So, but now let's load this. For example, many people here wrote Python. So let's see which Python version we have. There's two ways of searching. You can either use avail or spider. Both have slightly different, like do slightly differently. And then we see, okay, there's BioPython, BXPython, IPython, and some normal Python, and some stuff which contains Python somewhere, like here, netcdf Python.
And this ML is a shortcut for module?
Yeah, ML is something I use all the time. It's a shortcut in the sense if you just write ML, it's module list. If you write ML and then a package name, like for example this one here, then it behaves as module load. And wherever you otherwise would use module, is for example module avail, you can also use ML avail instead. So it's a nice shortcut. It saves you like 4 letters, and you can use it as module list or module load without any. So I always like to save on, because I'm a very like lousy typer. And then, okay, so but now we have a Python, and we can see this. And then now suddenly like we have all these new modules, and the last one is the Python, and the other ones are all like requisites.
And if I don't like it anymore, how can I unload it?
You can purge, then you get like rid of
Mm-hmm.
all of them. Now if I check this, we're again back to the standard env only, which is sticky. So this S means sticky, so it's not, if you unload or purge, it's not unloaded until you force it. There is this keyword. Okay, so now we can see like what software is available, but our original plan was to talk about how to install new software. Should we start with that now?
I have maybe one more question about the modules, but so now we learned how to load them, but when should I load them? When I log into the machine, or in my bash RC, or in my job script? What is the best practice?
And
I mean, I have an opinion there too, but
I know that. Okay. So it depends a bit what you want to do. Like if you want to work interactively on the system, you are trying something out, and you are like, for example, I want to try something like is there a certain Python module available? I will do this interactively. Maybe I load it. Maybe I can load Python, and then I can check it out here with Python, like what version do I actually now have? Can I import certain things? This you can, of course, you do while you type. If you work interactively, of course, you load the modules when you need them. But most of our work should not be interactively, but through job scripts. And then I would strongly advise to put those in your job script. Because it makes it a lot clearer to you and maybe to your colleagues if you give them the job script, or to us if you have a question, something doesn't work, what you're actually doing. Because if it's in your bash RC, we don't usually see that. You send us your job script, and then you don't know what like other software you might have loaded in your Bash RC. Of course, you can send us your Bash RC, but then if you have maybe different jobs which require different software, then it gets a bit messy in the background. So I think it's always better to load it, like put the modules you load in the beginning of your job script. Then for everyone it's clear. And yeah, and use the whole path. So like Python 3.10.8. So the whole module, so that you're not suddenly like confused because like the Python version changed. If you only write ML, does it actually probably work? Only write ML Python.
I think it doesn't work. I think we require versions, which I think is a good thing.
Yeah. This is maybe not the best time. I should have pushed first.
Let's try it out.
Yeah, okay. So I have to use module spider to see which Python version are actually available. So you have to explicitly tell the system which version you want. It's not just implicitly, because sometimes this happens. You install a new model version and then or module, and then suddenly you have a new Python version, a new open form version. Yeah, someone here added in the documents. You can of course also unload just one module by writing module or ML unload and that module name, and then you can only get rid of that one. Well, here, for example, like this. And I have like all these, and then I can unload, for example, only this part. No, I loaded it again. And if I list now, like only this one is missing, but all the other ones are still there. Depends on what you want to do. Sometimes module unload. Sometimes you want maybe purge to get rid of all.
So to summarize, and I think this was really good advice, is that when we test debug, when I'm testing my new calculation, it's okay to module load here now interactively. But once you have it debugged and you are ready to submit a number of calculations, then you want to have it in your job script. And the main motivation is to make it easier for other people, but also easier for your future self, because you will come back to your calculation in a few months, and then you want to know what are the modules that I've loaded, and it's nice if it's close to the computation. And it also makes it easier when you send us a support question, because then we see it. Otherwise, we have to guess it.
Yeah, that's very important for us. It makes it a lot easier. Also, if you like for your future colleagues or for your future self, like your future self is you should speak nicely, and sometimes it helps you to give you a hint in the future of what you're actually doing that moment.
Yeah, somebody said a sentence that I really like, and that is your two main collaborators in your academic career will be your past self and your future self. So let's be nice to them.
And like in my experience, my past self is mostly an idiot, but not always, at least. That's my goal. Okay, so now we know how to access software which is installed. Now let's talk about how to actually load software, or like install new software, because you can always install software. Like you can always ask us, but sometimes this might take a while. Sometimes we tell you that we don't see the need, like you should maybe do that, like install it yourself, because maybe you're the only one who will ever use that software. Okay, and there's different versions, like different ways of doing this. So okay, back to the documentation down here. On this left side, there's software, and then a lot about the module scheme, a lot more about than like how to unload, load modules or something, but also like here, installing software as a user. And this that you can of course write us, but also there's a list of like an overview of the different ways of installing software. And some are of course like if you like installing R libraries is if you need R. This is only interesting for you, but like Easybuild and I think Conda are the ones which are like ways of installing software, or like general software, not just like Python packages or R libraries or parallel modules. But we will start with Easybuild because it's nicely integrated in the module system, and it's also what we use to install software most of the time. So let's start with Easybuild. Okay. So everything I will talk about, you can also read about here, like a bit of background and installing software in your home folder, and like everything we will talk about is here. And we probably also like, I will copy some commands and look them up. But for now, what is Easybuild? And how can we use it?
Yeah, I hope you can show us. So the good thing here is that I'm relatively new to Easybuild. So I only use the end product, and the end product are modules. But here I'm here to learn about how to really use it to install. So the way I understand it, it's a framework where there is a big community of people and different computing centers who collaborate on sharing configurations on how to install software. So these configurations they are then somewhere on the internet. So there's a huge library and community, and we can install software through this framework, where we then depend on that somebody has written a configuration for that software that we are just installing. So all the instructions on how to download it, how to configure it, how to maybe compile it, where to place it. So it's a helpful thing so that I don't have to do all these different steps manually. So that's how I understand it.
Yeah. And just to be clear, all these steps like downloading, unpacking, compiling, or whatever, like all of them are like in a machine readable form, and the system takes care of it. So someone wrote a recipe for installing, and you just basically using it. And you can also write your own, or you can adapt some. But today we will only talk about using install scripts, or like they're called easy configs.
I like the name recipe. That's a good description. So it's a huge compilation of recipes on how to install software.
Yeah. And the command we will use for all of these things is called Easybuild. So I can type EB and then it's not found. So what do you know? Well, hint, there is a module, Easybuild module. So let's use avail or spider Easybuild. And then let's see here. There's only one available. That's why I see already more information with Spider. This available would look slightly different. And here it's a software installation framework written in Python, actually. So, and so we have this version available. And now let's load this.
And is it true that most our modules are actually built using Easybuild? Is that true?
Yeah.
Yeah. And here
almost everything we do is installed with Easybuild. And you will also see like all these like names like Python / 3.10.8 - GC core or something is the nomenclature that Easybuild uses. We will see that. But now EB should be available. Yeah, and it always writes a lot, and especially if you don't call it as anything, you get typical help text. There's a longer one available, but and for now, because until now we don't know much, but that's in the documentation. I think back in the days I wrote RJAX as a tool that we could install, but we can also try maybe something. Should we try something where we know kind of that it works, or should we try something which someone here on the chat, for example, console or cogender, if this is we
could try something new, but let's also make sure that this is like free software and not something licensed, proprietary. Yeah. So that can be a little bit complicated. So I would like that we try something that is open source.
Okay, but then
and I don't know. I have a feeling that console is not, but I'm not sure. And the other software I don't know yet, but I can do some search.
yeah, we can see if we can install this Easybuild. We can actually, I mean, probably best we first search with console if it's not available. Yeah, no modular extensions form. So it's not available on the system yet. Maybe it's available with Easybuild. We can see this. We did not script that part. There is Easybuild -S for search. There's slightly there's different search variants. -S is the easiest to remember, so we will go for this now, and then we can just look for console and see. And there's actually an Easybuild recipe available. So Easybuild always will have this like found valid index. So blah blah blah. You can ignore that line. Means there's easy recipes basically at this here and saved here. And then it does something which is it lists all of the ones. Since we are out, there's only one line. And what we're interested in is this part here. The part before is just like the abbreviated path to this Easybuild file. We don't need that. We only are interested in the actual like file name. And this is console version 540225. Okay. Now we have different, like we could have it, like we could look at the file. Should we do that? Maybe like a short?
Yeah, let's have a look. How does a recipe look like in?
Yeah. Okay, then let's copy this path here and then so let's just have a look. And then you see, okay, it starts with the name console, the version, there's a homepage usually linked, there's a description, like is a general purpose software platform based on numerical methods. Okay, multiphysics. Then there's a toolchain, which sometimes is like GCC or something. In this case, it's system, which means it's built on like globally installed system libraries instead of like bringing their own. And then you see a bit of what it does. Ooh, yeah, that doesn't look like we can install it. Yeah, there's a tarball you need from a DVD, so it's
from
not
DVD?
publicly available.
Right. Okay, let's take something else.
Yeah, it's not publicly available. A source code, like you can't download it from the onto the internet. So while there is there is an Easybuild recipe, it doesn't mean in this case that we can actually run it. Okay, then let's use something.
I mean, we have here participants who use Python. What if they need a Python version that we don't have? Maybe we could take that.
Okay. Let's see then. Let's look for Python and see. And now there's a lot. And yeah. Oops. It's a long list because, as you see, Python is sometimes used in the toolchain basically. So here VL or VC with. There's a version, and then there's Intel, and there's Python. So this installation depends not only on the Intel toolchain, but also on a certain Python version. But this means it's like very hard to figure out actually like the real Python. There's so many other things. So we can help a bit with that by, instead of searching for Python, we search for Python / I think that worked.
Maybe it's it.
Yeah, also. Huh.
Okay, what if you go back to before and then you pipe it into grep and then we grep for Python /.
Yeah, okay. Good. Then we do that. We do the old school approach and then look for Python / I guess. That's at least a bit better. You could restrict it a bit more, but now it's not that many. I mean, it's still a lot of Python version because there's Intel Python and all of those, but now you see like there's a long list of Pythons. And for example, I think the newest one we have on the system is currently 3.10, if I remember correctly, but there's already a 3.11 one available. So we could use that one.
Maybe let's
for
try
example,
that
if you're
one.
interested. Yeah. And like sometimes you see here there's multiple ones, and then you can sometimes you have different tool chains. Here's like this one is same tool chain, but this one is bare, this one is without. In this case, it helps to look at the file and to see what the differences are. But in our case, there's only this one, so I will copy that. And then let's jump to the back. To install this now, we can. The general command is just this: Easybuild and then the name of the module, and that's basically it. But if I want to run that, I add -D for dry run. That means Easybuild will not actually install it; it will only show what it will do. So it's like I call it a test run, and I would always like do that first, because then now we get a nice list. Now my screen is a bit too small, but here we see there's a temporary log file created. It tells me that okay, it found again, like before, it found like easy configs in this file folder, which is not important now. And now it does a dry run, and it shows me all the modules that are needed for the installation of my Python module. And there's like a whole.
If you get no errors in the dry run, does it mean that the actual run will work?
I mean,
hopefully.
Okay. It should. As always, problems that can arise, but you see, there's a whole list of modules which are being used, or that are required to install Python. But for us, quite luckily, most of them have an X here, which means they're already installed. And actually, it tells you also like, okay, this is this module it can load. And you see here like the module name and the Easybuild config are basically the same. Like ncurses-6.3.eb turns into ncurses/6.3, and the same for like the more complex ones. So module name and easy config name is very related to each other. And then we see like all of them are needed, but already installed except for the last one, which is the actual Python version. This is now a very nice example one, because that means we don't have to install 20 modules, which take a while. Okay. So now I could install this just doing this.
So I have a question before you hit enter, but.
No, yeah, I did not want to hit it.
Yeah, okay, good. Because my question would be, so where does this stuff go to?
Yeah, and that's a very good question, because all of those modules I see here are all installed globally at this moment. I did not install them. Someone from the software team did. And that means they're globally accessible to everyone. But if I install this one, I don't have any privileges to write in globally accessible files or folders. So this one will not be installed into like a globally a global software directory, but instead it will end up in one of my folders. And typically, or the default is that it will end up in your home folder. And maybe don't do this now. Like I'm in my home folder. I can print that, cluster home, and then my username JD. And if you look here in this the documentation, it sees like by default, Easybuild will download, build, and install software in a directory called .local Easybuild, which is this works. So, or at least it usually works. But what is a problem if you install into your home?
Well, if you install a lot, at some point, the quota will be full, the disk quota. So that's what I expect to happen.
How can I check actually how much quota I have currently? Or how many files?
The usage.
The usage. So
here you go. You have in your home, you have 80,000 files or inodes, out of 100,000. And it's already changing color, which means that it will be soon we can fill up. So we can fill up the quota not only by the size, so the space, but we also by the number.
And this is something many users run into, and also happened to me many times, that I install, usually actually installations. It's not that I copy them many files, but installations. They will come to back to that later with Conda, because it's a big problem. These installations create lots and lots of files, and then you easily have like another 25,000 files, and then I would run into my file quota, because every user and every like project or home folder has a space and a file, like number of files, number of folders and files. So I know it's quota. And if you hit that, then you can't write anything any longer to your home folder, which will give you like a whole like lots of different error messages. But often they contain disk error, disk error. Disk something basically that I think we will show later. It stops the work. So installing to your home you can do that. There's probably some reason that makes sense, but for most software you install, we advise you to, instead of doing it in your home, do it in your project. Because the project has a much higher file quota here. See, 10 million, for example, in this case, or 1 million at least, so 10 times. And usually also higher space quotas. But is there another advantage of putting it in your project, not in your home?
Yeah, there is another advantage, and that is we can make it available to all my colleagues in the same project, and they don't have to go through the same install effort.
Yeah, and it also means, like your whole project, if you have multiple people working, all of you save a bit of space and a bit of file quota, because instead of having the same tool 5 times installed, you only need it once.
So I have a practical question, and that is, looking at the time, we are 10 minutes before 10. What is our plan with break? When are we taking the next break? How far are we?
I would say we install Python now with Easybuild, and then we have a break. So in like 10 minutes.
Sounds good. So 10 more minutes and then we'll break.
Yeah, and if you have any kind of questions, put them in the, like here in the HackMD. Yeah. Oh, he used HackMD before in the Markdown document here. And if you, I'm not sure if it's supposed to check somewhere, but it's the same as yesterday or the days before. Okay. So we will actually jump ahead of installing in your home, because it's more advisable now to do it in your. Is it not mentioned here? I thought it would. Oh yeah, here, installing software in your project folder. I don't see the left side. So here. So we call this semi-globally because like other people in your project can also like access it, but it's not globally available to all the users of Saga, of Drama, wherever you are. And it's actually really like simple. You just we define a path. Let's call it modules or something. And I put that to cluster projects. And if I mistype, you have to correct me. And which one do I use? 999. Okay. And
wait a moment. The number was different. If you want to use the cross account, it was different.
Yeah.
Checking. Checking. It's, I think, 9987.
Okay. Then we use 87 projects. And then it depends now. If you install for your project, you can of course just put it here and call it then like Easybuild. Or because now this is a shared folder and you also want to do the same, I add my initials or my username. But it's still available to everyone in the project. Yeah. this is just, I define this variable now. And now I make here. So I make minus P just means like make all the subfolder, the folders before that one if they don't exist, and then my goes. I should have just copied that from my path. Naja. Okay, and now I can run my installation. What was it here? Easybuild. Maybe I just copy it in here. And instead of just like doing a dry run or something, I add, or just like installing it to my home, I add prefix. And then the variable I just defined. I mean, you can of course also just copy the whole path, but that way you only have to define once. Okay. So that be, maybe let's do like -d one more time, the dry run, so that we know what's happening. Okay, looks good. Okay, that looks good. So let's try that. And now without -d, and let's see what's happening. So now it will go through a lot of steps. So it will fetch the files online, it create a building directory, will unpack the files we downloaded. Now, some of these steps take a while, so we can talk about other things. What I haven't shown now is what would you actually do, Radovan, if you have an installation and we do a dry run to see like what will happen, and it would show like multiple packages here which are not installed. Like for example, here the X would be missing as well. So I have 2 or 3 or more packages which are not already available.
I mean, what
do I have to then what do you think happens, and what could we do?
My expectation is that Easybuild will then see that it needs dependencies, it installs first the dependencies, and then it automatically installs what I wanted. So my expectation is that I don't have to do them one by one. Is that true?
Yeah. Yes. Oh, this is what you expect nowadays. I mean, you don't want to like if you have 20 to like issue the same command 20 times with different package names. And I mean, Easybuild is aware of it. But if you will try that, you will actually see that you will get an error, basically warning you that it does more than one thing. And if you don't know what to do with it, it feels like you have to go to them step by step. But maybe we can see this here. Oh, that's fun. Nah, the example doesn't contain it, but what it will do is it will give you an error, but you can just put at the end of the installation here. There's my command here. You just write --robot or just -r, which means it will install all the dependencies it needs automatically. And then it behaves just like you are used to from like Conda or from your package manager, your local package manager, maybe if you use Python. Oh my god, the unpacking takes longer than I expected. Thank you. Should we wait for it?
How long do you expect the whole thing to take?
I did not look at what it would actually do.
Because we take a break and then we hope that when we are back from the break it's done and then we can inspect it.
But in general, there are some where this takes some. It's basically the Easybuild just downloads some files and unpacks them and puts them in the right folders, and that takes a minute maybe, because there's not much happening. It just does some. It creates a module file in the end. We will see that, and some can take quite a long time. So like half an hour or more, because it has to compile everything, and compilation takes time. It's a quite intense process for the computer. So, and I did not check which one this is now. So if it takes way too long, maybe we take the break now. If it takes way too long, I think I know one which is installed much quicker, and I can do this in the break. And then we see what happened, like how it looks when it's finished. Okay. Should we have a break till 10 past, maybe?
Sounds good.
So someone tried to do what I do, but you got an error. Make dir minus p, like so this command, and it gave the error missing operand. And I think this is caused because you did not define so this is a variable, and if you call that again, you have to put a $sign before it. But here we define the variable. So we basically set it, and then we created a folder, an empty folder in that case, and then we set this as an installation prefix or the installation folder. So I think what you did is forget to define this line. So just write my modules equals like something similar to that one. Okay. Good. While this was compiling, because I actually now aborted it, we can go up a bit here. It took 4 minutes for the configure part alone, and then it was building. So I think this would have done, I don't know, at least a few minutes, maybe in half an hour, or it could be longer. I remembered something which I forget, and which you are not very, like, you don't make the sysadmins happy with that. Is if Easybuild really does something like where it uses a lot of computational power, it uses all the available cores. And since I'm on a login node, this is a shared resource, so all the users of Saga goes through over like a couple of login nodes, so 4 or 5. I mean, there's at least 5. Not sure how many are currently in active use. I think 5. And then I will use all the cores of that one login node. So quite some people might have like a slow experience when you do that, like I just did. So instead, what you should do is like use minus parallel and set it to like 2 or something here. Because that tells Easybuild to only use 2 cores out of the 40 or something we have. So next time I should do that better.
And we are still on
the.
So I just want to clarify, we are here on the login node, and
yeah,
and we said many times that we shouldn't do stuff on the login node. So is that okay to compile now on the login node, and how many cores?
I mean, yeah, I didn't expect this to be a compilation, so I did it on the login nodes. But if this would now take an hour or something, you should not necessarily do it on the login nodes, but instead do it on one of the interactive nodes, or do it on the login nodes and like use parallel type like 2, so that you only use like 2 cores, because I think that's reasonable. I don't think you are really bugging someone if you like run something for half an hour with 2 cores. But if you know that like they are shared resources, so if you know that it will take a lot of time, get an interactive job like it was described yesterday. Oh, yeah. Oh, I think we talked about how to get an interactive node and then do it there. It's possible that you have to run minus fetch before to download the stuff. Yeah, and we'll download it into a certain folder, and then you actually do the installation, because the login, not all nodes have access to the internet at this point in time. Okay, so I aborted this installation, and now I tried something different out. Julia, similar, like also a language like Python, and installed that, but otherwise similar, also with a prefix, so into the project. And as you see here, like it took 2 seconds to download the files, and then it packed for half a minute, and it prepared, configured, build, testing. Everything took like less than a minute. It does some sanity checking to see if the installation works in general. Usually it calls like the help function or something, or it does like look where some files exist. That depends on the module, or the recipe which we use, what happens here exactly. Then cleans up and it creates the module, because we use an easy config, so a recipe, to create now a module. And then permission package, and here, after 2 minutes, the installation was ended successfully. Okay, so now, and just to recapitulate, I installed Julia version 1.7 because the newest Julia version was already available and had to come up with something else. So if you look for ML available Julia, you see Julia 1.8.5, which is not the version I installed. And you can also see it's under cluster module files all, and not under my like projects. So what's happened here? Why can't I see what I just installed?
Oh, because I think the module command doesn't know that it should look in there.
Yeah, I mean, yeah, it's kind of like, why? How does should module know that there is some module files in some of your project folders? It can't go through all of the folders and files on the system to check if there's modules, so you have to point it there. And that's what I haven't done yet. So what we have to do here, if you look in the documentation, is this is not for your home, but it works the same as you have to use something called module use. So module use, and then the path to the files that I just, so I can use my modules. And modules and all is a bit nicer, but it also would work if I just would write in the modules. Then if I check ML available in Julia, then now I can see, okay, here are actually now 2 different versions in 2 different folders. So this is a globally installed ones, and these are my project installed ones. And now I can, for example, load ML. I just copy that. And now Julia is available to me. So that worked. So, but this means if you install stuff yourself, try it out. It's not hard. As you see, do it into your project file. So use the minus prefix, maybe define a folder like I did, then install it there. There's a minus prefix here. And then don't forget to module use. And you have to use modules every time you log into the system. If I remember correctly. So put it in your job script. This just like this line. I mean, be careful with this line. If I put that into my job script, it might not work because if my modules is not defined in the same job script, it might not. But you can also, of course, use the whole path. So this just use module use and then this. And this also makes it then very clear where this is installed. Like if you give it to your colleague and they don't know, where did you get the software from? It just writes here, module use here. And then you know, okay. If it's not in the globally installed, it's there. This is like the one thing you can trip over if you install yourself, that you can't see the files then because you forgot to basically point the system towards where they are installed.
So
okay.
both module use, long path, and the module load, both of them should be in a run script, ideally.
Yeah, I would say so.
Good.
If you work a lot interactively, you can put it in your bash RC as well, but you can also put it twice. I don't think anything happens if you run the same command. You can try this here. This module use a long path in this case. No, I don't have it. Okay, then just reuse it. This one. Yeah, so you could also put it in your bash RC, but I would also still advise you to put also in your script, in your job script, so to make it really clear that you're using a self-installed module, at least at sometimes. Because if you give your job script to your colleague and they don't have this line then in their bash RC, they can't find the software, even though it's there. and available to them, basically. So put in your JavaScript, and it's also, everyone can run it who's on the same project. Okay, I think this was enough about this was quite a lot now about Easybuild, the system we use.